Today, I am going to discuss about the data structure trees. Tree is a hierarchical data structure. That means in trees, the data nodes are arranged in a hierarchical way. It is a non-linear data structure. What do you mean by non-linear data structure? So what is a linear data structure? Linear data structure is a data structure in which the data are arranged one after another. That is, the data nodes are read one after the another. That is, we follow a linear fashion to read through the data structure. But in nonlinear data structure, for example, in the given diagram, it is a tree. Here, if we want to read the data nodes, we can follow different paths. For example, 2, 7, 2, 10, 6, 5, 11, 5, 9, 4. This is one way of reading the data nodes. Another way I can follow like this 4, 9, 5, 6, 5, 11, 10, 2, 7, 2. There is no specific order to follow the data nodes. That is why it is called as a nonlinear data structure. So here, the data are stored in something called as nodes. These nodes are also called as vertex. These nodes are connected by using edges. These nodes maintains a parent-child relationship. For example, here 7 and 5 comes under 2, which are the children of 2. And 2 is called as the parent of 7 and 5. See again 2. 2 is the child of 7 and 7 is the parent of 2, 10 and 6. So here the nodes maintains a parent-child relationship. Now, there are different type of trees, and binary tree is one among them and is very important. Binary tree is a special type of tree in which every node or vertex has either no child or one child or two children. That is, the maximum number of children of a binary tree is 2. It cannot be more than 2. For example, C8, it has 2 children. C3, this node is also having 2 children. Now C14, it has only one child, 13. And C4, it has no children. That is, when we see this diagram, we can identify that the maximum number of children of any node is 2. So it is a binary tree. Every node on binary tree stores one or more data and 2 link parts. Since it has only 2 children, it has only 2 link parts. One is for the left child and another one is for the right child. The binary tree can be empty. If the tree does not contain any node, we can say that binary tree is empty. Now, the binary tree can be classified into two types. One is full binary tree and another one is complete binary tree. What is full binary tree? A binary tree is also called as a two tree, is a tree in which all the nodes other than the leaf node has exactly 2 children. Okay, a full binary tree is a tree in which except the leaf node, all the other nodes will have 2 children. So this is a full binary tree. Now suppose I am taking off this node and this node. These two nodes are not available. Then also it is a binary tree. What is the condition of full binary tree? Every node should have two children except the leaf node. Okay. So suppose this node, if this node has only one child, it is not a full binary tree because as per the definition, this node is not a leaf node. So it should have two children. Then only it is a full binary tree. Next one, complete binary tree. A complete binary tree is a binary tree in which at every level except possibly the last has to be filled and all nodes are far left as possible. So in a complete binary tree we should fill the nodes from left to right order. That is, here we have A, then B, C, D. This node cannot be empty if these two nodes are existing. Okay, so it cannot be empty. Here, this node should be available. Okay, now F, G, suppose here this L, this node, if it is the uh, right child, then also it is not a complete binary tree. Without filling the left side, the right side cannot be filled up. So, complete binary tree is a binary tree in which the node should be filled from left to right order. Now, there are so many terminologies related to a tree. We see some of the terms related to tree data structure. The first node of a tree is called as the root node. The root node is always at level 0. The level is counted from 0, 1, 2, 3, likewise. Now, C is the child of A and the parent of F and G. The children of the same parent node is called as the siblings. So here F and G nodes are having the same parent C, hence they are called as sibling. But E and F are not having the same parent, so they are not siblings. If a node has no children, it is called as the leaf node. So F is a leaf node, G is another leaf node, J, I, H, all these are leaf nodes. And a big tree is composed of many child trees or many subtrees. So see here, this is a subtree. It involves one parent and two children. This is another subtree. Okay, this is another subtree. So a single tree consists of many subtrees. Okay, so we saw what is a subtree. Now visiting. We want to read the nodes of a tree, and this process is called as visiting. If we read the data of a node, then it is called as visiting that node. Another term is traversing. Traversing is the process of visiting every node of a tree, at least one. Okay, so traversing is visiting every node of the tree once. So we can read the entire data in the tree by traversing through the tree. Now level. We have already seen level. The level will be counted from 0 from the root node onwards. Each hierarchical level is counted as 0, 1, 2, 3, etc. Now keys. The data stored in every node is called as the key. Okay. Now root we already saw, parent we saw, and child node also we saw, sibling we saw. If uh, 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 sibling is two nodes which has the same parent are called as the siblings. Next one, path. Path is the number of successive edges from source node to destination node. See here, A is the source node and J is the destination node. We can see the path from A to J as A to B, that is one edge, B to E, another edge, and E to J, another edge. So, this is the path from A to J. Similarly, from C to K, C, G, G, K. This is the path from C to K. So, path is the sequence of nodes and edges between two nodes. Now, height. We can say the height in two different ways. The height of a node and height of a tree. What is height of a node? See, what is the height of a node A? Height of a node A is the maximum length from A to one of the leaf node. So A to C, C to G, G to K is one of the path. Okay, so A to C, C to G, G to K. Now another one, height of B. B to E, E to I. That is the height of B. So in this way, we can find out the height of a node. Now what is height of a tree? Height of a tree is the height of the maximum height of any node is the height of the tree. So here if we take the maximum height is the height from A to K. So A to C, C to G, G to K is the maximum height. So how many edges are there? 1, 2, 3. 3 edges are there. Hence the height of the tree is 3. Next one, the important term degree. Degree of a node as well as degree of a tree. Degree is the number of children attached to that node. So the degree of A is 2. Degree of B is 3 because it has 3 children. The degree of G is 1. The degree of H is 0. So among this, the highest degree is the degree of B, which is 3. Hence, the degree of the tree is 3. Now, we will discuss about some of the properties of binary tree. For a binary tree of depth k, depth is same as height. The maximum number of nodes at level I is 2 power I, where I is greater than or equal to 0. So for example, we can say, what is the maximum number of nodes at level 0? 2 power 0, that is one node. That is only root node is available at level 0. Now level 1. only 2 nodes are there. So according to the equation 2 power 1, only 2 nodes are available. Now in level 2, 2 power 2, that is 4 nodes. In level 3, 2 power 3, that is 8 nodes. See, 1, 2, 3, 4, 5, 6, 7, 8. This is the maximum number of nodes available in each level. Now, another property, the number of nodes n in a full binary tree of height k is at least 2k plus 1 and at most 2 power k plus 1 minus 1. That means in a full binary tree, the maximum number of nodes for a full binary tree of height k is 2k plus 1, 2 power k plus 1 minus 1. So this is um, this is a full binary tree of height 3. Okay, its height is 3, 1, 2, 3. 3 edges from root A to L. So its height is 3. This contains maximum number of nodes. So we apply in this equation 2 power k is 3. 3 plus 1 4. 2 power 4 minus 1. That is 16 minus 1 15. See how many number of nodes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 nodes are there. As per the equation, the rule is true. Now the next one. The least number of nodes for a full binary tree. So this is a full binary tree of height 3 with the minimum number of nodes. Okay, so this is a full binary tree, see, because every level is filled from left to right, and every node has 2 children. Hence, it is a full binary tree with the minimum number of nodes. Now we see its height is 3, and the least at least it contains at least 2k plus 1. So 2 into 3 plus 1. 6 plus 1, 7. So 7 nodes are available in this one. 1, 2, 3, 4, 5, 6, 7. Okay, so the equation is found to be proved. Now, a full binary tree with L leaves has n equal to 2L minus 1 nodes. If a binary tree has L leaves, it has total number of 2L minus 1 nodes. So how many leaf nodes are there in this one? 2, 4, 6, 8. So what is the total number of nodes? 2 into 8 minus 1. That is 15. That is the total number of nodes in this binary tree. Now the next one, for any non-empty binary tree with the n0 leaf nodes and the n2 nodes of degree 2, n0 is equal to n2 plus 1. So for a non-empty binary tree with the n0 leaf nodes, how many leaf nodes are there in this one? 8. So 8 leaf nodes and n2 nodes of degree 2. How many nodes are there with the degree 2? 1, 2, 3, 4, 5, 6, 7. 7 nodes are having degree 2. So n0 is equal to n2 plus 1. 8 is equal to 7 plus 1. So the condition is also proved to be true. So these are some of the basic properties of binary tree.